Hey, welcome back. I'm Ernest. I've been building out this data engineering pipeline and I made some updates to it. Just a recap, this is an end-to-end pipeline for a fake food delivery company. We have a Python script generating thousands of delivery events, and then the data for these events gets loaded into our S3 bucket. And once it's there, it gets loaded into Databricks, where we do some cleaning to the data, and then finally it lands in our dashboard. And this is what our dashboard looks like. In this dashboard, we can have an overview of what our food delivery operations look like. That's the whole pipeline, and honestly, it works pretty well on its own. But there were things that I wanted to try and improve on. The improvement that I wanted to make was to add some kind of orchestration to the pipeline. So before orchestration, this is how the pipeline would run. This Python script automatically runs at 5 minutes past every hour. So right now it's 1 p.m. So that means it would have run at 1:05 p.m. Once the Python script runs, then it will run the AWS S3 sync. Then I've scheduled this Databricks pipeline to run at 15 minutes past every hour. So that means it would have run at 1:15 p.m. This whole thing would have run at 1:15 p.m. So the idea is that I scheduled this to run at 5 p.m. and then 10 minutes is plenty of time for it to run. And then when 1:15 p.m. hits, then the pipeline would run. But sometimes this doesn't always work. Because imagine like what if for some reason at 1:05 p.m. we just have a lot of data and it took it a really long time to put it up into the cloud. Maybe that took 15 minutes. So that means that it would only have finished running at 1:20 p.m. That means even though this part hasn't finished running, the pipeline would have been triggered and then it would ingest no new data. Then at 1:20 p.m. when the data finally gets into our cloud storage, we would need to wait until 2:15 p.m. for it to run again so that we get the data from 1:05 p.m. Now you might think, hey, it's not a big deal. Just wait another 1 hour so that the pipeline runs again and then you get your data. And in a lot of cases, yes, you're right, it's not a big deal. But sometimes for certain type of data, it can be a really big deal. So imagine like what if we're actually dealing with financial data? What if we're trying to track the stock market? People are literally looking at the graph and seeing all the changes happen in real time, right? So like they're literally like watching it like a hawk. And so imagine if I said, hey guys, like something went wrong with our data. You just gotta wait for 1 hour and then the data will come back up, but don't worry about it. They're not gonna accept that because every second counts, every second matters, and they might lose a lot of money. They might lose a lot of money because of that. So by the way, this idea is called eventual consistency. So like think about what that means, right? Eventual consistency. Eventually, this data will be consistent. So even in this scenario, when our data arrives an hour late, it eventually arrives. So in some situations, eventual consistency is okay. And in the other situations, eventual consistency is not okay. So that's when Airflow comes in. Airflow is an orchestration tool. We can say, hey, at 5 minutes past every hour, I want you to run this whole pipeline. And I want you to make sure that each step finishes before the next step happens. So that's really all it is. It's just a slight upgrade from having that gap where we say, hey, this runs at 1:05 p.m. and then this runs at 1:15 p.m. and hopefully nothing goes wrong. But then now it's like, okay, like we're gonna run this at 1:05 p.m. and then we're gonna make sure that each step runs before the next one. Okay, so before I show you what the Airflow DAG looks like, first of all, let me maybe show you what a DAG is. So a DAG stands for a directed acyclic graph. So at its core, it's actually nothing complicated. It's literally just a graph. And a graph shows a process. So each of these nodes are a process. And then the arrow is like, okay, after process 1 finishes, then we're going to go to process 2 and process 3. So it's really the same thing as a flowchart. So when you hear DAG, just think about a flowchart. You are literally just describing a process flow through a diagram. So let me go into the code a little bit. So in this Python file, we are declaring what the DAG is. So we're saying, hey, our DAG, the name is called food delivery pipeline. And then it starts on June 1st of 2026. For the schedule, currently we don't have a schedule for it. But I can say like, hey, I want it to run at 5 minutes past every hour. That's what this expression means, 5 minutes past every hour. Or you can also say like 15 minutes past every hour. Or you can also say every 2 hours. You can describe it however you want. But right now, we're just gonna keep it as none. So catch up is actually pretty cool. Right now it's set to false, but if we set it to true, it's gonna look for any data gaps. Airflow is gonna look through all the runs for our pipeline and it's gonna see if there's any gaps between the start date, which is June 1st, and now, which is June 20th. So maybe like on June 2nd, for some reason, the pipeline didn't run. Like maybe there was like some kind of bug and then it just didn't run for that particular day. Well, catch-up is gonna detect it and then it's gonna run it for June 2nd and just like catch up for you. So that's what catch-up means. And we also got retries and retry delays. So for example, if I run it today for June 20th and it runs into an error, well, it's gonna retry up to 2 times. And then it's gonna wait for 2 minutes in between each retry. And sometimes that honestly just fixes it. Sometimes you just gotta turn it off and on like a computer, right? Like your computer isn't working, just like freaking turn it off, turn it back on, and boom, like it just works. Okay, and below the DAG definition, we also have the definition for the individual processes. So this one is the process that generates those food delivery events. This process takes the data that has been generated and then syncs it to our S3 bucket. And trigger Databricks, as the name suggests, will trigger the Databricks ETL pipeline to run the new data that has been generated. And at the bottom, we just define the process flow. So we just say that, okay, generate events is gonna happen first, followed by sync to S3, followed by triggering Databricks. Okay, so once you've done configuring your DAG, then Airflow actually has a UI, a user interface that you can interact with, and it shows you your DAG. And so that's my food delivery pipeline DAG. And if I click into it, we have this graph view that makes it really clear what we're doing right now. And it also shows how each task is dependent on the task before it. I'm gonna just trigger it so that we can see what that looks like. Okay, so it's loading right now. Okay, there you go. So generate events and sync to S3 just ran. Now the Databricks one is running. So I just logged into my Databricks and right now you can even see that the job is actually running. So it's a good sign. All right, so the Databricks job just finished running. And if I look at my Databricks, yep, it confirms it. The job was successful. So that's Airflow, man. That's literally so cool. Like, wow. So yeah, if you want to stick around to see where this goes, drop a subscribe and a link to the GitHub repo is in the description as well. All right, I'll see you next time.